on as of late with Theron, right? He's kind of involved in this too. So Theron is a committee member, works at Tall Timber still, right? So Ryan has worked closely with Theron on what he's going to present today. So Ryan came to DSU, what, about 10 years ago, I think now?
Yeah, I think it was
Yeah, so he's had a lot of bad luck. His first field project completely failed, and I was going to talk to you about that, but I think Ryan's just going to give a brief background on that first field project. So he did some field work. The project ended up being a complete failure, right? Yeah. Well, I don't know whose fault it was, but I don't know if it was anybody's fault. Maybe the weather. But that failed, so Ryan had to reset halfway through, or even later maybe. And luckily, Theron had this data set for Ryan that he could evaluate and do some modeling with this data set. So that was pretty fortunate. There's been a few other bad luck things I think that Ryan's run into along the way. But finally, he's here. He's going to defend today. Hopefully, we can get him a master's degree in August, and he can be on his way. But so Ryan graduated from University of Delaware in Wildlife Conservation, right? In 2006. He lives in Smyrna, so he's local. He's a native Delawarean. Currently, though, works in Maryland as a habitat biologist for Maryland DNR. How long have you been there?
I've been in the Maryland DNR since 2006, but in the current position since 2016.
Okay, so a while. Okay, so I guess that's it for my intro, and we'll let Ryan present the data that he's been working on there.
First of all, thanks for everybody for coming out today. I know it's the end of the semester. I think we're probably kind of hectic right now. So as Dr. Hetcher alluded to, I started back in 2009 with a field project that was going to look at kind of just general bobwhite quail habitat and survival information at Chino Farms, located in Chestertown, Maryland. We had done some field work in the fall of 2009 and the winter of 2010. And then unfortunately, we had a series of bad weather events, constant snow, frozen weather for the whole month of January and February. Basically killed off our entire population of bobwhites, or at least about 98% of the birds died off due to heavy snow and ice that was present on the study area. So kind of went through some kind of tough and apprehensive times there for a little while. Luckily, Theron had some research data that his crew had worked on through Tall Timbers at a plantation down in South Carolina, and they needed all of this data pulled together, evaluated, analyzed, written up. So we were kind of fortunate in that we had kind of a backup plan there, because I'm not sure what would have happened otherwise. I've been in a lot of trouble, after that. So I took several trips down to Florida to work with Theron on this project. Took a trip down in, I think, 2015, and again in fall of 2017 to work on analyzing this data. So finally, after all these years, we're here today and going to present this data that I've been working on. So the title of this presentation is an evaluation of a northern bobwhite parent bird release in South Carolina. Before we get into kind of quail and more of the specifics, just looking at grassland birds in general, through the last several decades, even the last century or so, they've experienced large range-wide declines, really more so than any other gills of North American bird species. And this can mainly be attributed to the loss and degradation of early successional habitat, mainly through the more intensive modern agriculture practices, habitat fragmentation, urbanization, afforestation. We have less management of our forests nowadays, and then the lack of fire on the landscape. We've had several generations of people that have grown up thinking, through the media and whatnot, that fire is bad. And we've been kind of snuffing out fire on the landscape, and a lot of that is starting to change now. We're starting to get fire back on the landscape, so hopefully we can start to turn the tides on this. This is, these declines have been seen both on public and private lands, and it's caused a reduction of both consumptive and non-consumptive resource use. To reverse these declines, first and foremost, sound habitat is an absolute must. But this is challenging, especially some grassland bird species, especially our model species in this study, have low dispersal capabilities. And doing habitat management on the appropriate scale and a more fragmented landscape is a big challenge. And then also another challenge in today's world is a rise in predator abundance. There's been a decrease in trapping and a reduction in the fur trade market. And then also the protection of raptors is also cause for predator abundance to rise on the landscape. But even when proper habitat is restored, abundance of these animals may be too low to allow for recovery. So to augment this, not just with grassland birds or any bird species, but with other animal species as well, reintroductions and translocations have been used in areas where species are currently absent in areas of high quality habitat. These are mainly successful with species with high rates of increase, and they're generally considered successful if they produce a self-sustaining population. But these animals must survive long enough to breed, and then not only survive long enough to breed, but to also produce young that are capable of breeding as well. But one huge hurdle with this is that it requires a reliable source population. If you're going to do translocations, you have to have a landowner or somebody that's willing to give up some of their birds for you to use in your translocation study. So this is kind of brought about the problem, or to look for alternative restocking techniques, which would allow for population recovery on a larger scale. So having said that, will bring us to our model species here, northern bobwhite. They're a good candidate or model species to look for alternative restocking techniques. They're probably successional habitat species. They're popular North American game bird, and they've experienced large range-wide declines in recent decades. Historically, they were found in approximately 35 states. That range is now down to about 25 states, and they've seen about a 4% per year population decline from 1966 through 2015. And again, like we said before, this decline is mainly due to the large-scale loss of habitat through modern farming practices, urbanization, fragmentation, afforestation, and then the lack of fire on the landscape. Just in general, quick bullet points about quail, some characteristics of them. They're, adults are approximately 170 grams, 19 centimeters in height. They form these coveys, or what are called coveys, in fall and winter to kind of help with survival through the winter time. And these consist of approximately 10 to 12 individuals. Their habitat is mainly consisting of approximately a third of native bunch grasses, 1/3 forbs and legumes, and then 1/3 protective cover. And this is a big one here. This habitat requires active management. Quail used to be kind of a byproduct of the landscape. Farming practices in the early part of the century were a lot more dirty, I guess you could say. A lot more fields were left fallow. Herbicides were used a lot less, so there was a lot more weedy cover on the landscape. Farmers used fire to clear the land. Native Americans used fire to clear the land. All this contributed to a more robust bobwhite population in the earlier part of the century. But we've kind of been snuffing this active management out, and that's one of the main reasons we've been losing these birds. So their diet consists of seeds and insects mainly. They nest from approximately April through September, even in the southeast. This can even be into October, but mainly April through September. They have kind of a complex breeding cycle. They can have multiple nesting attempts, multiple mates. They can produce multiple broods, and they even have some male incubation also. Annual survival is quite low, only approximately 25% of individuals survive through the year. And they have the nickname the Firebird because fire is absolutely critical to maintenance of their habitat. Without the absence of fire, they're not going to do nearly as well. So just some general pictures of what bobwhite habitat looks like. In the top left and bottom right are kind of what's typical of bobwhite habitat in the southeast. These pine savannas, mainly longleaf and lava-like pine savannas with low basal area, 30 to 40 basal area. Forests with undergrowth of native bunch grasses and legumes. And then also a few pictures there of some other native grasslands with some clumps of protected woody cover kind of dotted about the landscape. Just a map of kind of the historical range of quail. I got this from the National Bobwhite Conservation Initiative. We've kind of lost some of this northern fringe of the range. So states like Wisconsin, Michigan, New York, PA, there's states up there. These birds are kind of extirpated. So this range map is in recent years has kind of contracted down to this 25 states, like I had mentioned earlier. A graph here showing that this general decline of not only bobwhites but also of grasshopper sparrows. And you can kind of see here this large decline with both bird species from the mid-1960s on until today. So it's not just quail that are experiencing this decline; it's other grassland bird species as well.
So Ryan, which color is which?
Now the quail are on the bottom and the grasshopper sparrow, but regardless of who's on, which one represents which, you can see this general decline with the general large decline with both species. So to kind of augment this this low populations in certain areas, so bobwhites in many areas are still absent or in very low numbers even after sound habitat management practices have been put in place. So to kind of augment this, researchers have experimented with several restocking methods in recent decades. This first one, pen-reared birds, is kind of considered a quick fix. A lot of the hunters like this method. These birds have spent generations in captivity. They have no parental care. Basically, they're hatched out, they're raised until they're old enough to survive or to be flying on their own, and they're released out into the wild right before hunting season. It kind of augments the quail population on the landscape, so hunters have something to go out and shoot. Basically, is basically all these birds are really good for. They have a very low survival. They can also transmit disease to native bobwhites. They can displace native bobwhites on the landscape. They can also increase the mortality of native bobwhites. So when you release these birds in the landscape, they're kind of stupid, basically. They really have no survival instinct. So they're kind of out there being sitting ducks, and they're going to attract large number of predators, which are then going to also kind of get this search image to where they're also probably going to prey on native bobwhites as well. If they're able to survive to the breeding season, they can also dilute the native bobwhite gene pool. And all these challenges with pen-reared birds are likely due to the lack of imprinting on these birds when they're hatched out. The other restocking method that's been tested is and been proven to be very successful is translocation. There's multiple studies out there where this has proven to be successful, and in areas of high quality habitat, it's actually never failed. this is taking place just prior to the breeding season. So birds are trapped in one area and moved to another area just prior to the breeding season. But this is not always feasible. Public lands could have a challenge. Many public lands have policies and whatnot against moving or releasing certain animals on their properties. The cost of moving these birds is high, but the major hurdle to overcome with this method is a reliable source population. So you have to have a landowner being willing to give up some of their bobwhites to be translocated and for your study, and especially around here and even in the southeast, this is, landowners just don't want to give up these birds because they're in low numbers already, and giving up some of your birds is not going to help your population also. So Palmer 2012 came up with an alternative restocking technique called the parent rearing method that involved adopted parenting of captive reared chicks. And it implemented pre and postnatal imprinting on these birds. And I'll get into the actual step-by-step process of how parent rearing works in a minute. But it implemented pre and postnatal imprinting that had a positive influence on survival through predator recognition, predator avoidance, recognition of alarm calls, food selection, and parenting skills. So this allowed them to kind of mass produce pen-reared birds that had wild bobwhite characteristics. But as in a lot of research, more research is needed to kind of look at the factors that influence the success of this method. There were two other studies that were published recently, Lunsford and Macaluso, that were not successful. They didn't have any birds that survived until the breeding season, unlike during Palmer's study. And we'll get into some of those other studies as we go along. So I obtained field research data from Tall Timbers Research Station. They had a parent rear release study in South Carolina that they conducted. So as I go along, the field methods were not conducted by me. They were conducted by Tall Timbers research staff. I did the analytical analysis of all this data. So as I go along, just keep in mind that the field research or the field methods that were conducted were not my own. They were conducted by the Tall Timbers research staff. So I evaluated survival and reproduction of both parent-reared bobwhites and wild resident bobwhites that were present on this study area. So in the survival chapter, my first hypothesis predicted that the timing of release of parent-reared bobwhites impacted survival, timing of release impacted the survival of parent-reared bobwhites. The second hypothesis was that survival of parent-reared birds was lower than resident bobwhites in the first few weeks post-release. And then after this, acclimation period survival was similar between the two bird types. And then the third and final hypothesis for the survival chapter was that parent-reared bobwhites had a larger home range and thus had increased mortality due to possibly greater exposure to predation. And then for the reproductive chapter, Palmer 2012 was the only parent-reared study so far that's looked at reproduction of parent-reared bobwhites. So I predicted that the nest survival rates between parent-reared and resident bobwhites was similar. And then the final hypothesis was that the other reproductive parameters, nests per hen, successful nests, broods per hen, and chicks per hen were similar between these two bird types. So before we get into any of the specific methods in the survival and reproductive chapters, just a brief overview of the study area. It was a private plantation in Georgetown County, South Carolina. It was mainly made up of lobwood pine savanna, with the rest of the habitat made up of longleaf pine savanna, bottomland hardwoods, and then fallow fields. And the understory was made up by, with a lot of these native bunch grasses, little loose stem, big loose stem, broom sedge, and then some protective cover, blackberries, salt bush, and wax myrtle. That a subtropical climate, it's approximately 1.5 meters above sea level. And then the active management activities consisted mainly of prescribed burning on a 2-year rotation and winter disking and also some timber thinning as well. And then bobwhite hunting was also an activity that took place on the study area. It's a quick Google map showing kind of where the study area is. Myrtle Beach, South Carolina, if you're familiar with it, is located up here. Our study area is located down this way. Then we have Georgetown, South Carolina down here, and Andrews, South Carolina, located down here. And then just a closer look at the boundaries of this study area. So getting back to this parent rearing process. So wild strain bobwhite eggs were obtained from abandoned nests from Tall Timbers Research Station. And these eggs were then hatched in an incubator and they were raised in a brooder. And these birds that hatched out from these abandoned nests were then used to lay eggs, and the chicks that hatched from these eggs were then used in our study. So essentially the birds that were released on this study area were 1 generation removed from the wild. So prior to these birds hatching out, a hen vocalization call was played approximately 36 hours prior to hatching to start this imprinting process. Once chicks hatched out, they were placed with a wild strain foster parent to begin this imprinting process. And then they were placed in the brood and parent were placed in a rearing pen for approximately 35 to 42 days with minimal human contact. They were fed a diet of Milo of Milo and millet, and the rearing pens contain natural vegetation. So those methods in the study area and the parent rearing process are going to be the same between both the survival and the reproductive chapter. So moving along to the methods used for the survival analysis. So wild bobwhites were trapped in the winter and spring of 2011 and the winter and spring of 2012 using funnel traps. These are square type traps. They're basically maybe about 1 meter wide, I guess you could say, with funnels on either side and the baits placed in the middle, basically. And they're checked at sunset every day. So they were baited with corn and sorghum. Once the birds were removed from the traps, age, weight, and sex were determined, and they were marked with a numbered leg band. And then a subset of the birds received a VHS necklace style radio transmitter. And these were only put on birds that weighed more than 132 grams. So these parent reared birds in this survival analysis were released at approximately 6 weeks of age in 2011 and 2012. One cohort was released in August, and then one cohort was released in the early fall, late September, and one of the cohorts were released in early October. And this coincides with the natural peaks in hatching. And a subset of these parent reared birds received a 3-gram VHS necklace style transmitter, and all of the parent reared birds were tagged with a uniquely numbered Batagio wing tag. As far as telemetry goes, they were located approximately 2 to 3 times per week to assess survival and home range using handheld Gauge antennas. And they were located using the homing method by fully or partially encircling the birds to obtain their locations. Their locations were then recorded on aerial photo maps, and radio collars that emitted a mortality signal were then recovered immediately. And then the cause of mortality was determined. It was categorized by either large avian, small avian, mammal, hunter harvest, or unknown. And this was based on evidence at the kill site. So getting into the analytical approach which was more of my focus of this project. I used program mark. I used a known fates model in program mark to produce two candidate model sets. I assessed weekly survival, or I assessed survival on a weekly basis from August 1st of every year until April 30th. And then for each encounter, the birds were either marked as alive, dead, or censored, meaning they weren't hurt. Either there was radio failure or they moved off the study area or some unknown reason. So this first model suite looked at temporal effects to look for this weekly time period post-release that explained the most variation in the data. So we were looking for, or I was looking for, a time period post-release that had the highest amount of survival. Like we said before, we were looking to see if there was this acclimation period for these parent-reared birds. So I came up with model sets that tested for a weekly effect on survival, anywhere from 1 week up to 8 weeks post-survival, and then also a model with no weekly effect. And then for these weeks after the weekly effect, survival was held constant for those weeks. To rank these models, I used a multimodal inference approach, AIC, to rank these model sets, and the model set with the lowest AIC value was considered the best approximating model. So this is just an example of what an encounter history would look like when you put it into mark. So you have to put these encounter histories into Notepad before you then import them into program mark. So starting here on the left, that's the unique number for each bird. So each bird had a unique number. And then each encounter history basically encompasses two numbers here. So if the bird was alive at the beginning of the encounter, if the bird was alive at the beginning of this encounter history, it was given a 1. If it was still alive during this time period, it was given a 0. And then at the next time period, it was considered, or it was encountered alive at the beginning of that time period. And then if it died during that time period, we would assess, or we would put a 1 down for this encounter history. And then for all the other encounter histories throughout that, then we just list zeros. If there was a sensor in there, you wouldn't put anything, you would just put a 0 in for the censored birds. And then these numbers over here on the side coincide to the different covariants that I was looking at that I'll get into here in a minute. They coincide with year, time of release, bird groups, old release. So there was a parent bird study that happened on this study area a few years prior. So there may have still been some birds still alive after that parent bird study. And then the last number there is the home range for each bird. So moving along with the analytical approach, the second model suite that I developed was a group covariant effect. I looked for the effect of year, bird type, time of release, and home range on survival. And then I also included the highest ranking temporal model. So for year, I had 2 different covariants. I had two different cohorts. There was 2011 to 2012, and then 2012 to 2013. Bird type was broken down into resident versus parent-reared birds. Time of release was broken down between August and fall release. And this allowed me to isolate and evaluate these individual covariants on survival. And I developed models using these covariants by themselves and then a combination of these covariants together. And again, I use AIC to compare these candidate model sets. And the model with the lowest value was considered the best approximated model. I evaluated home range using a 95% kernel home range for birds with 20 or more telemetry locations. And I used the add habitat package in program R to do this. So looking at the results of the survival, there's 328 bobwhites that were evaluated for survival throughout both years, 162 in 2011 and 166 in 2012. Resident birds, there was 211 through both years, 101 in 2011 and 111 in 2012. Parent reared birds, there was 116 birds evaluated for survival. In 2011, there were 61, and in 2012, there was 55. This August release cohort, there were 76 across both years. 2011, there was 40 birds. 2012, we had 36. And this fall release, there were 40 birds across both years. 21 birds in 2011, and then 19 birds in 2012. So the average weekly survival across both years was low for both. So weekly survival across all years of bird types was low. So it was approximately 88% weekly survival, which compared to some other studies in the Southeast, average weekly survival was upwards of 97%. And some other studies that have been done in the Southeast. When it was evaluated by itself, year did not have an effect on survival. And I detected no effect of home range on survival. This could have been due to low sample size. There were only 29 birds throughout both years that actually qualified for home range analysis. 20 resident birds, and then which had an average home range of 11.35 hectares, and then parent reared birds. There was only 9 that qualified for home range analysis, which their average home range was approximately 12 hectares. So, looking at this covariance kind of separately here, the fall release had a negative effect on parent reared survival. This August survival was up around 89% for parent reared birds, and it was about the same for resident birds during that time period as well. But as you can see down here, fall release survival was only about 71% of weekly survival. This parent reared bird type had a negative effect on survival. These parent reared birds had an average weekly survival of approximately 78% across all years. And then resident birds had approximately about 90% survival.
Ryan, just a real quick question. I apologize, but these are pooled across years, is that correct?
Yes.
Okay.
Yeah.
Thank you.
So, looking at these temporal models rankings, I found that a 3-week post-survival or a 3-week post-release interval was the best fitting temporal model. In this model, the 3-week survival was held constant for those 3 weeks. In the second model, the second ranking model is a time-dependent model where survival was allowed to vary between those or during those weeks, and that was done for all the from 1 week up till 8 weeks survival. But I found that the 3-week post-release interval was the best fitting temporal model. Looking at the rankings of these group models, I found that a model consisting of the 3-week interval effect and then an interaction of year and bird type explained the most variation in the data. But the second ranking model, I think, should also be taken into consideration as well. That included 3-week survival interval and then this time of release. And then the rest of the models basically didn't rank very high at all. So these results, getting back to kind of my three hypotheses that I stated earlier, these results support my prediction that the timing of release has an effect on the survival of parent brood birds. As we saw previously, this August weekly survival was approximately 88%, and September-October survival was down around 70%. The results support my hypothesis that survival was lower immediately after the release, and we found that it was approximately 3 weeks post-release that had the highest mortality rates. And then in contrast to my hypothesis, I found that home range did not differ between these bird types. So this 3-week survival interval is not something unique to just my study. Lunsford actually found the same thing in his study of parent brood birds, and the same results were seen with Terhune 2010 with translocated bobwhites. So this survival was, or overall survival was lower than what Palmer 2012 found, but similar survival rates from my study, had similar survival rates to Lunsford and Macalosa's studies. This resident survival was lower than other studies, like I mentioned previously. So we didn't really test for any effects of habitat here, but there could be an effect of habitat that's causing these low mortality rates or these low survival rates for both resident and parent brood birds on this study area. So there was only, at least in these 2 years, there was only 2 parent brood birds that survived till the breeding season. Less than 2% of these birds survived till the breeding season, which is not adequate. So Palmer, this is in stark contrast to Palmer, found that 14% and 30% across both years of this study survived until the breeding season. So this variability between these bird type survival is very concerning for this method. So survival only differs slightly between years, but it's worth mentioning that weather conditions can have a big effect on habitat conditions. Higher rainfall in spring and summer can have a positive effect on vegetation and insect abundance, which in turn is going to have a positive effect on bobwhite abundance on the landscape, and the reverse can also be true. So if you have drought conditions, you're going to have a negative effect on vegetation and insect abundance. Weather conditions can also affect the predator context. So raptor migration is weather dependent, and cold fronts routinely push raptors into this area during certain times of the year. So if there's higher raptor populations on the landscape, it's likely going to have a negative effect on bobwhite survival. So these releases, and this is true for many different types of studies, these releases should be implemented across multiple years to kind of help buffer against these yearly variations of weather. So as we saw before, the time of release had a big impact on parent brood survival. This August survival was almost 20% higher survival rates. Again, they didn't measure vegetation composition during this study, but it would have been very helpful if they did. But it's possible that there was better concealment for birds in August. In the fall of the year, due to changing weather, vegetation may have been starting to change, leaves starting to drop and whatnot off the vegetation, which allows for less concealment from predators and likely a higher mortality rate of birds. And these later releases may have also coincided with raptor migration as well. And then there was an unpublished study done in Maryland a few years ago that had an 18% 3-week survival, and this coincided with below average nighttime temperatures. So it's also possible that these lower nighttime temperatures could have also had an effect on chick survival as well. So this time of release, where we had a higher August survival, is in contrast to what Palmer found in his study. He actually found just the opposite, that that September birds had a higher survival rate till the spring trapping season than August release birds did. So these, and again, these releases, if possible, should be timed to coincide with lower predator numbers on the landscape. So to kind of wrap up some of the survival chapter, so survival will vary substantially between these different study areas, between these different studies that have happened between year and then the timing of release. So if this method is going to be a successful restocking method, there's a lot of refinement that still needs to be done. One thing that hasn't been looked at that I think would positively impact survival is conditioning these chicks to predators. This was not imprinted on chicks when they were used in this study. It was successful with these Hubra bustards, these birds that are found in Asia and Africa. When they were parent-reared birds, and they were exposed to red foxes prior to release, and this having conditioned to these predators had a positive impact on their survival once they were released. The varying age of release could also be looked at deeper. Lunsford found in this study that parent-reared birds that age at release had an impact on survival. I believe he found that chicks that were 9 weeks old had the best survival rates amongst those birds. And then releasing these chicks with adoptive parents. So when they're released without the parents, and they're basically on their own. So releasing them with these adoptive parents possibly could improve predator avoidance and possibly foraging behavior as well. So that kind of wraps up the survival chapter. I'm going to move on to reproduction. A lot of, like I said, the study area, parent rearing process are all the same. So I'm not going to go over that again. So as far as capture, tagging, and releasing of birds, so my analysis of reproduction did not take place in the same years as the survival analysis did. So parent-reared birds were released on this study area in the summer and the fall of 2008 and 2009 without radio transmitters. So these birds were only tagged with these uniquely numbered Batagio wing tags. So in the winter of 2009 and 2010, these birds were trapped using the same trap styles. Transmitter attachment was the same as in the first chapter. So when these birds were trapped, they had bird type determined. Again, the parent-reared birds had these uniquely numbered wing tags on them, and they had age, weight, and sex determined. And then 4 to 6 individuals per covey were outfitted with radio transmitters. Telemetry was the same. They were located approximately 2 or 3 times a week during the breeding season. They were tracked from April 1st until September 30th in 2009 and 2010. So to determine nest success, potential nest sites were flagged after the birds were located in the same location for approximately 2 consecutive days. And these nest sites were confirmed when the adults were away from the nest. The nests were checked daily to determine clutch size, predation, hatch date, whether they failed. So they were determined to fail if they had no eggs hatched or the adult was predated. And they were considered successful if they hatched at least 1 egg. So for the analytical approach, I used the number of hens alive on April 15th, so that's kind of considered the unofficial start to the nesting season. So I used the number of hens alive on April 15th to assess the nests per hen, the number of successful nests produced, the broods per hen, chicks per hen, and this was done for both resident birds and for parent-reared bobwhites. in 2009 and 2010, and I also pulled the data across both years as well. So I used the nest survival model and program work to make these encounter histories. I used the Julian date that the nests were found. So the encounter history included the Julian date the nests were found, the date the nest was last active, the date of the fate of the nest, and then the encounter history was given a number, either 1 or 0, depending on if it was successful or failed. And then the 2 different covariants in the model were year and bird type. And I produced models with these covariants by themselves and in combination with one another. And again, we used the AIC to kind of rank these models, and the models with the lowest values were considered the best approximating models. So here's an example of what an encounter history would look like for the nest survival model. You have these, you have the number of the birds here on the left, and then the date the nest was found, date it was last active, the date of the fate, and then you have the covariance over here. So 70 hens were alive on April 15th across both years of the study, 30 in 2009 and 40 in 2010. Resident birds had 45 hens alive, 19 in 2009 and 26 in 2010. Parent reared birds, there was 25 hens, 11 in 2009 and 14 in 2010. So resident hens produced a total of 28 nests. They produced 10 in 2009 and 18 in 2010. Parent reared birds produced 16 nests, 7 in 2009 and then 9 in 2010. So looking at this nest survival model, daily nest survival rate was approximately 96% for pooled across both bird types. And it was almost exactly the same. We broke it out between resident birds and parent reared birds. So the most parsimonious nest survival model, basically the top ranking model, was this naive survival model. Basically, it was a model that didn't include any covariance of bird type or year. So the covariance of bird type and year did not help explain any of the variation in the nest survival data. So we can see a ranking here of the different types of models that I ran. This naive survival model is the top ranking model. And the second model is the survival model that took years into consideration. So just kind of charting these different metrics. And that's for these are just charted, they haven't been statistically analyzed, but to see if there's actually a difference between the two groups. But just charting it out here, the nests per hen looks similar between bird groups. Both parent reared and resident birds produce multiple nests. They both produce, or they had hens, or 5 hens that produce multiple nests. Successful nests, resident hens produce more successful nests across both years. Broods per hen, just looking at it this way, that parent reared birds across both years produce more broods per hen than resident hens did. And then chicks per hen, parent reared birds again produce more chicks per hen than resident hens across both years, but resident hens number was slightly higher in 2010. So these results support my hypothesis that nest survival and reproductive metrics were similar between both bird types. The nest survival rates in this study were similar to what was found in translocated bobwhites. Terhune 2008 found identical rates for translocated bobwhites when compared to resident bobwhites. And like I said before, this was not evaluated in other parent reared studies, so this is the first time nest survival had been analyzed for parent bird birds. Like I said, before this, naive survival model was the highest ranking model. And this was the same that Tertiary in 2008 saw in his translocated studies of Bobwhites. But this isn't unexpected. So nest survival can be influenced by vegetation and weather. But nest survival is primarily driven by mesomammal predation, foxes, raccoons, armadillos, skunks. So these two bird groups were affected by the same predator community. So these other reproductive metrics were similar again. This was consistent with what Palmer found in his study. Parent bird birds also re-nested readily. There was one bird that I found that re-nested 3 different times in 2010. So this ability to re-nest greatly aids these birds in their population growth potential. So kind of getting back to some of these penbird birds that we mentioned at the beginning of the presentation. So Palmer looked at penbird birds and compared their reproductive metrics also. And he found that the penbird birds actually nested just as readily as resident and parent birds, but that their nest success and their chick survival was low. They displayed a lack of birding activity, and their predator avoidance was lacking as well. And this was likely again due to this lack of imprinting. So similar results here we're seeing with other parent bird species, providing further evidence that pre and postnatal imprinting is critical in aiding and parent bird restocking efforts. So to kind of wrap up this reproductive chapter here, looking at the reproductive chapter alone, this shows promise as a restocking technique. But that's only if birds can survive until the breeding season. And this overwinter survival is a huge hurdle to overcome for the success of this method. The translocation method kind of mitigates this overwinter survival since birds are released just prior to the breeding season. It takes advantage of the high reproductive potential that these birds have. But this isn't a viable option for parent bird birds. You have to keep them in captivity for 6 or 8 months. And the time and cost involved in that would not be practical. So further research needs to be done into the number of parent bird birds that need to be released to elicit a positive population response. And then also maybe looking at chick survival of parent bird bobwhites. So these birds are producing, the same or nearly the same chicks per hen as resident birds, but if they're not caring for these chicks, if these chicks are dying, then maybe this isn't a viable. Maybe these birds aren't, nearly as good as reproducing as we thought they were. So to kind of wrap this all up here, tying both the survival and the reproductive chapter together here. This low post-release survival, I think, likely precludes this method as an adequate restocking technique. The results from my first chapter here, the results of Lunsford and Macaluso, I think preclude this method from being a viable restocking technique. Even with these future modifications, the number of birds that are likely needed to elicit a positive population response is likely too costly and time prohibitive for it to be effective. So future bobwhite management, first and foremost, should focus on sound habitat management. Without sound habitat management, anything else you do is basically going to be pointless. So if you have sound habitat management and you have proper habitat on the landscape and the proper amount of habitat, the augmentation of wild bobwhite translocation into areas of low density, I believe is the only other possible or viable restocking technique that there is. It's been proven to be successful, and we should work to implement translocation in certain areas where we deem that it's viable and able to be done. So that kind of wraps everything up that I have. Just some short acknowledgements here. First, want to thank everybody for coming out again. Thanking Pablo for broadcasting this over the web here for fair review. Thanking my committee members, Dr. Heckscher, first and foremost. I guess he took a chance on a student that was kind of a non-traditional student in a way. Likely some of the students here I've probably never met. I'm not here on campus. I don't know much at all. I have a full-time job, so I was kind of a part-time student and took a chance on that, and I'm grateful for that. All my other committee members, Dr. Golnick, Dr. Fox, Dr. Green, thank you for all your help along the way and encouragement. There's been a lot of bumps along the way, and the positive encouragement was certainly helpful to kind of push me through the end here. And then a huge thanks to Theron. He's gone kind of above and beyond what I would have expected any committee member to do. He's opened the doors to his research facility for me to come down to Florida, work with him one-on-one. I mean, I went down there for, like I said, a week, basically 2 weeks, to work with him one-on-one. So I'm forever grateful for his time and efforts that he's put into this. All my incessant emails to him, silly questions over the years. Like I said, forever grateful for the time and effort that he's put in. The folks, not only Theron down at Tall Timbers, but the other research staff down there, they're at the forefront of bobwhite management, and everything they're doing down there is kind of laying the groundwork for all future bobwhite management that we're doing. They provided me housing when I went down there, a free place to stay. So that greatly helped. One of his other biologists, Diana McGrath, provided assistance with using Program R and home range analysis. So I'm thankful for her efforts as well, taking a couple of days out of her schedule to help me with that. And then, like I mentioned before, my employer, Maryland Department of Natural Resources, without their encouragement for me to go out and better myself, and the ability and their willingness to give me time off. I think I have one of the greatest jobs in the world. I can, we're very lenient with time off, and when we want to go out and better ourselves, they're all for that. And if I wasn't given the time and encouragement to go do this, from them, it wouldn't have been possible. So I'm sure I'm missing some people there along the way, but thanks again for everybody coming out and your efforts. And I guess we can open it up to questions after that.
Questions for Ryan? I have a question. Do you know what portion of bobwhite's diet is insects? In the wild.
Well, as chicks, it makes up almost all their diet as chicks, and then once they get older, they kind of convert more over to seeds. And of course, in the wintertime and whatnot, it's mostly all seeds because that's all that's available. But as chicks, I think it's upwards of like 80 or 90% of their diet makeup.
Like most birds.
Right. Yeah.
So a follow-up on that, you sort of mentioned the abundance of insects and being, in droughts and things, but what you didn't say, there's a lot of farmland there, a lot of pesticide spraying.
Right.
Now, could this in any way be related to mortality of chicks?
Or in this study area, or,
Well, in general, I mean, all the studies that,
and I don't think so much in this study, because, I don't think agriculture was as big a part on this study area. But in other studies, and just in general, I don't know that directly has an impact on survival. Like, I don't think they're getting sprayed by pesticides and they're dying, but
no, I meant
pesticides are having an effect on insect abundance for sure.
that's sort of.
Yes, I mean, that's a huge factor with this modern
Well,
agriculture.
we've had 90% of monarchs
Right,
disappear. Obviously, they're probably not eating monarchs, but
right,
the same is true with our pollinating bees, the native bees.
Yeah.
So then you would expect all other insects would
Right.
also be suffering.
no, I mean, that's
That's
definitely a factor, and chick survival.
Any questions, Brian?
I'm in the queue, but I'll hold till the committee.
Yeah, I'm sure your committee's got some
Yeah.
questions, I'm sure. Most of the room is your committee, so. I will ask you one question though. So, you addressed the reason why just stocking them in the spring wouldn't work. Logistically, I think you said, right? Because, data would suggest if you could successfully do it in the spring,
Right.
then they might be able to get established and reproduce. But, I mean, it seems to me that at least someone could try keeping a population over winter within a predator exposure
Right,
of some size. I mean, is anybody,
no,
are you basing your conclusions on literature that says this won't work, or, you know that it won't work, or
No,
is this just off the top of your head?
it's basically just assumptions that I made on my own. So I think that's something that could be researched. I mean, it hasn't been looked at, but if you can kind of mimic this translocation studies and release them just prior to the breeding season to take, advantage of that reproductive potential, I think it might work. But there hasn't been any studies into that, so I can't say for sure what the cost of that would be or how much time that would involve. But I think it might be an area to look at for future research considerations. I wouldn't completely rule it out. It seems like, at least to me, that it would be, time and energy into it, that I just wouldn't think it would be, advantageous to
Well,
do.
yeah, and a large scale might be impossible.
Right.
It would be nice, I bet you could conduct an experiment.
Yeah,
And if you had super high survival, it might be worth it.
Right.
Others,
Yeah.
So. See if there's anything else on that. Yeah, I think I'll hold off on the rest for afterwards, but anybody have a final question for Ryan? All right, thanks.